This right here is a good example of a motherboard that is on its way out. This computer system come to me with bad capacitors and motherboard, and the power supply itself had some bad capacitors as well. The SCSI controller was bad, and the original hard drive would cause the BIOS to hang. I believe this computer here was hit by a power surge. I recapped the motherboard and managed to get it to work okay, but everything was real slow in it. Took the SCSI controller out, that isolated the slowness issue, but the motherboard still acted somewhat unstable, especially after being on for about 5 or 10 minutes. Then it would crash and restart. But today, motherboard can't even get past the power on self-test without crashing and resetting. It just goes through a continuous cycle over and over and over again. It's a good example of why you should always use a decent power supply in your computer system. Here shortly I'll be cracking open the old power supply and have a look inside. That power supply, I believe, was in this machine its whole life. And as you can see, the motherboard is pretty much shot in this computer. So I'll be replacing the motherboard. I've already put a different power supply in it. This is what we're getting right now. Okay, I just got through working on that computer, and here is the original power supply from it. This is the power supply that damaged the motherboard, damaged the SCSI controller, and damaged the hard drive that was in the computer, the original components. This power supply is a fine example of absolute cheap garbage. I mean, there are power supplies out there that are inexpensive but still are built with the correct specs nowadays, the proper outputs, that sort of stuff. So anyways, let's have a look at this one. This power supply here is called Just PSUs USA Incorporated. At least they're nice enough to include the manufacturer, which is Channelwell. Obviously they're not a very good manufacturer. Let's have a look at these outputs. It says max output. Not rated output, but max, more or less peak output is 425 watts. Let's see, output on a 12 volt rail is 12 amps. Output on the 5 volt rail is 40 amps. I mean, that's 200 watts right there on the 5 volt rail. So it's kind of obvious this power supply is a old 1990s spec power supply that they just slapped an ATX 12 connector on and said it was Pentium 4 ready. Let's keep going here. 3.3 volt rail is 28 amps. That's a lot of power just on that rail. Minus 5 volt rail is 1 amp. Minus 12 volt rail is 1 amp. And obviously the minus 5 volt rail tells you this is obviously an old design. And the 5 volt standby rail is 2 amps. Now of course we all know by just looking at these components inside this thing that this thing can even put out those rated outputs anyway. I mean, it's kind of obvious. Let's have a closer look here. Let's have a look at this. Using my flashlight to get a little extra light in here just to give you a better idea how the internals of this thing actually look. Actually, it's better off with just a halogen. Anyway, notice around this heatsink, notice the dark coloration on the PCB around some components. And look at this transformer, you can tell it's been hot too. This power supply has suffered some serious heat damage because the original fan failed in it. The owner of the power supply, or the owner of the computer more or less, does have some technical knowledge, so he would replace the fan himself. But there really is no telling how long this thing ran without a fan. Obviously it was going for quite a while without a fan, because I mean, look at this. Oh, it's this coloration, this darkness on the PCB, all that. That right there tells you this thing has suffered some serious heat damage. And we have 3 bulging capacitors over here on the output side. That's not good. Get an even closer look here at this thing. I mean, this is absolute garbage. Look at that itty bitty bridge rectifier. At least they bothered to use one. But put it this way, 250 watt power supplies have bridge rectifiers that are much larger than that. I mean, by a big shot. I mean, look at this. This thing's so tiny they had to stretch the wires out just to get into the connectors on the power supply. That is sad. And these capacitors, they look really small. This is typically what you would find. These capacitors here, let's spin this around a little bit. See if I can get the ratings on them. These are, let me see, 330 microfarad capacitors. And usually, you'll find these in like 100 watt power supplies. Put it this way, I recently opened up an old 145 watt power supply from an old Gateway that was actually powering a Pentium 4 system, and its 2 primary large capacitors were 390 microfarads apiece. Normal 250 watt power supplies have 470 microfarad capacitors in them. Anyways, let's keep going. Have a closer look here. Inside here, you'll really notice that discoloration. I mean, it is pretty bad. Look at that. Around those rectifiers on the second heatsink. See, switching power supplies, you have switchers on this heatsink, and you have your rectifiers on this heatsink. More or less, a switching power supply works like this. You have your input AC power through here, and normally you have filtering components which are non-existent on this unit. Normally you would have a coil, 2X capacitors, 2 Y capacitors. We have one little bitty Y capacitor back here, which normally should still have an extra 2 up here. Anyways, the AC power comes in as filtered. In this case, it's not really filtered. It goes through these 2 capacitors, the only filtering that's available. It goes through these switchers, which the switchers can fine-tune how the voltage is on these units. That's why switching power supplies are used in computers. And the electricity runs through these transformers, gets rectified back to DC, and of course it comes out through here. Anyways, like I say, lots of heat damage. Now let's have a close look at those bulging capacitors. Surprisingly, they haven't started leaking yet. Oh, which, by the way, it does get a whole lot better than this. Let's look from this side at the PCB. There's a little bit of discoloration, but nothing like that right there. That right there is pretty bad. But it gets better. Have a look at this 20-pin ATX connector. Notice that real brown connection here? Now, normally when you get brown connections, this is when you force too much current through the connection itself. This can happen when you have a very cheaply designed connector, which this connector is cheaply designed, but the reason why this has discolored so much is because the power supply has fried the computer, or has damaged it anyway. The 5-volt rail must have went real high, because this is a 5-volt wire, and notice how the wire itself gets darker as you get closer to the connector. It just gives you an idea of how hot this got. Let's turn it around here. Notice here, we got 2 more. These are also 5-volt lines. It's a real wonder that motherboard managed to still work after I recapped it. But as you saw earlier in the video, it was in bad shape. Anyways, the SCSI controller was more or less fried in a way. The original hard drive would not actually boot into Windows, but I could access it using a USB adapter to an IDE cable. I mean, more or less, this is kind of this general idea why you should avoid really cheap power supplies. Even if you have to buy a cheap power supply, get something that's actually got a modern spec, which I'll show you something like that here in just a moment. Here's an example of a somewhat decent inexpensive power supply. This is a Diablotek PSDA 400 watt power supply, and is rated for 78% efficiency at typical load. Let's look at the outputs here. The 3.3 volt rail is 26 amps compared to 28 amps on the other one. The 5 volt rail here is 35 amps when compared to 40. The 12 volt rail is 15 amps when compared to 12. The minus 12 volt rail is 0.5 amps, and the 5 volt standby rail is 2 amps. This power supply here is, I would say, kind of in between. It's not really, I'd say, a good 12 volt source, but it does have some decent power at 5 volts and 3.2 volts. Though at the same time, this power supply doesn't have a minus 5 volt rail, so it is a newer design, as the white cable is also missing from the ATX connector. So let's have a look inside this one. This power supply is a used pull that comes out of an HP desktop computer, and of course this replaced the failed Bestech power supply that probably had bad capacitors in it. Let's have a look inside this one. Now, of course, we all know a unit like this won't actually be able to successfully put out 400 watts, but this one here is built better than that last power supply I looked at. At least this one has 470 microfarad capacitors and a slightly better rectifying bridge. It still does not have any filtering components, which I could actually solder those in myself. Real cheap basic power supply, but at least this one here is built a little bit better. No heat damage. Heat sinks are not that incredible. But surprisingly enough, this power supply actually has decent reviews on Newegg for the uses that it does get. Let's look at the connectors. Okay, here are the connections on this power supply. We have our main connection, along with our ATX 12 connector, which is a 4-pin connector. Let's see here. Here are 3 of the SATA connectors. And here's another one, so we have 4 total of these. Here's our floppy connection, along with 2 Molex here. And we have, let's see, 2 more Molex on this strand. So we have 4 Molex connections and 4 SATA connections, 1 floppy, a 24-pin main connection, and an ATX 12 connection. That's a pretty decent amount of connectors for such a power supply. Though I'm not impressed with the wiring. I don't like this 20 gauge wiring. It's supposed to have at least 18 gauge. But, I mean, for a cheap power supply, this is not too bad. But here's the burning question. Would I run this on a really decent setup? No. I'd run this on a basic setup. And of course, with this one here, I just wouldn't run it at all. It goes straight in the trash. Okay, so finally, let's have a look at a decent power supply that I only paid $25 for, brand new off a Newegg. Okay, and here's a good example of a very good power supply for the money. This power supply was only 25 bucks on Newegg, and even, I mean, Newegg doesn't sell these anymore, but if you're looking for a cheap power supply, this would be something to get, because it's built very well. The only issue with this unit here is that they didn't do a very good job with the capacitor selection in it. They decided to go with a cheap brand called JEE, which does not last but maybe 2 years tops before causing problems. Anyways, let's go over the specs on this unit. This is actually an older spec unit because it has the minus 5 volt rail, but it has 32 amps on the 3.2 volt rail, 42 amps on that 5 volt rail. Look at that, 42 amps. So obviously this is an older spec unit. It has 20 amps on the 12 volt rail, so 240 watts on that 12 volt rail. Not really something for running big time graphics cards, but you could still throw in probably a basic card, let's say like a 5670 or any other low power card that doesn't have a connection for a power supply. Usually anything like that you'll get by with just fine with something like this. And of course, don't run a 125 watt CPU with this. Run something like a 95 watt tops. The minus 5 volt rail is 0.3 amps, minus 12 volt rail is 0.8 amps, 5 volt standby rail is 2 amps. Of course, the newer units don't even have this, so anyways, let's have a look inside this unit. Now, normally, when you spend $25 on a power supply, you don't usually get hardware that looks this high quality on the inside. Let me go ahead and spin this around here so you can get a better look inside this thing. Okay, now we're looking at the filtering stage, the primary filtering stage on this unit, and you'll notice right away these capacitors. They are much larger than the ones in most power supplies of this price range. Most power supplies that are like $25 will have low-end capacitors about maybe 470 microfarads. Usually what you'll normally find in a good quality 250 watt unit. This unit here has 680 microfarad capacitors, which you can typically find these in 400 to 500 watt power supplies. Notice we have 4 of these white capacitors, those blue capacitors. The spec calls for a minimum of 2, so this unit here they've done a very good job on this. Go over this way, here is the rectifying bridge, and this is the inrush current limiter. This is a thermistor that limits how much power can flow through it when it's cold. This way it doesn't blow the fuse when you plug it in to a power source. Another very important thing that I didn't really mention much in these power supplies are MOVs, more or less your surge protection. This power supply has it. The other two don't. And of course here is our filtering choke. This yellow thing here looks kind of like a transformer. Behind it is this yellow X capacitor. So far I only see one. There should be 2, but it's not that big of a deal when you got all this other stuff here. But of course I could probably solder in another X capacitor directly to the AC plug if I wanted to. Anyways, I got the AC power unplugged. See, normally you can't do that on power supplies, especially ones in this price range. Normally you have to take a soldering iron and melt the solder to get the wires loose. And have a look here. This fuse is easily removable. So let's say you blow a fuse and you found out the problem, you want to install a new fuse, just pop it in. No soldering iron required. And notice here, another cool thing about this power supply is its paint job. Look how shiny it is. Notice I got it on this bubble wrap because I don't want to scratch it up. I want to be very careful with this thing because I don't want to scratch its paint job up. Should this hardware inside this thing fail for any reason, I could buy a brand new power supply and I'd actually take the board out of it and stick it in this because this case looks so good. And look at the fan grill. That's pretty neat. Anyways, back to the point. Here is the capacitor issue with this power supply. I've replaced this capacitor here. This is a Jamicom pulled from a WinTech. But the rest of them are the JEE capacitors. There's one blown here. Well, it's not blown, but it's bulging. This one here is on, I believe it is, I can't tell the voltage of it, but I think it may be on the 5 volt rail or the 3.3 volt rail. Actually, it's a 5 volt rail because these back here are the 3.3 volt capacitors, which we got one bulging back here. I had to replace the capacitors in the Black Max power supply, which I have 2 of these. If you haven't watched my previous video, this one here has been out of service since I'd say June of last year. I put it up in storage since then. And these 2 capacitors more or less started bulging in storage. These weren't bulging when I replaced this capacitor here. Anyways, like I was saying, I had to recap one in the Black Max because these capacitors failed along with this one here. This is only a 5 volt standby rail. This one here bulged, and it caused an issue to where I couldn't turn the power supply. Well, I couldn't turn the computer on. It was kind of difficult. It takes several attempts. You had to cycle off the power by cutting the switch off several times, and then try to turn it on again. Eventually, come on with. Of course, replace this capacitor, and everything worked fine. Let's continue on here. Let's look at the connections on this thing. We have good quality wiring, thicker wiring. This is what you want on a power supply, is good quality wiring. You don't want a lot of voltage drop just from the wiring coming from your power supply itself. Anyway, this power supply has 2 SATA connections. It's an older spec unit, and this power supply was probably designed back when SATA was only in hard drives, unlike it is with optical drives, more or less everything. But now you have your solid state drives, your hard drives, your optical drives, that sort of stuff that run on SATA. This power supply has 6 total Molex connections, and it has 2 floppy disk connections. Here's a 20+4 pin main connector, and notice this UV sleeving they got on here. This looks really cool inside the computer when you have cold cathode lights. The only disappointing thing about this unit, other than the capacitors, is they use thin gauge wiring on the HX12 connection. I mean, this is your CPU connector. I noticed a lot of power supplies from eMachines, the best tech units, do the same thing. Even the 300 watt units, the newer ones, have this thin gauge wiring going to your CPU connector. I don't like that at all. But anyways, this power supply is built very well for the money. I'm just real disappointed they use such poor quality capacitors. They would have used a decent quality capacitor. Heck, I'd have paid the extra $5 just to have better quality capacitors in this unit. Otherwise, this one here would have been very reliable without any maintenance. But of course, after replacing the capacitors with good quality ones, this power supply will last for years and years. So anyways, let's review. The first unit, it was a good example of absolute cheap crap. The second one was somewhat decent for the price. It had plenty of connections, but it had poor quality wiring, and the internals were not that great when you compare it to something like this. And of course, this one here doesn't have the best connection layout, but it has decent quality wiring on most of the connectors, has a good build quality, but has sorry capacitors. But I'd still choose this one out of all 3. So anyways, any questions or comments, feel free to ask.